afternoon, learners. Last classes we discussed about the consumer's behavior. Today you know about the production and production with one variable input. Production is require a combination of various inputs or factors of productions. With the joint efforts of these inputs like labor, machines, land, raw materials, that output is produced. Production is carried out under conditions of variable proportion, which implies that the rate of input quantities may vary. Fixed proportion production means that there is only one ratio of inputs that can be used to produce a good. In the short run, not all inputs are variable, but in the long run, all inputs are variable and the ratio of inputs may also changes. This is the case of technological progress. And there is in the short run, production function, whether it is shown, it gives the total output obtained from different quantities of the variable inputs given a specified amount of the fixed inputs. Suppose the case in which capital is fixed but labor is variable, so that the firm can produce more output by increasing the labor input. For decision making, the firm's manager must know how the amount of total output of product increase as the labor input increases. Here, a table is shown from where we understand about this concept. The output that can be produced with different amounts of labor and with capital fixed at 5 units. The first column shows the fixed amount of capital. The second column shows the fixed shows the amounts of labor from 0 to 10, and the third column shows the total product or total output. From the table, we find that when labor input is 0, output is 0 also, because capital alone cannot produce anything. Then up to a labor input of 7 units output increasing fast at an increasing rate, then at a decreasing rate in response to increased use of the labor. The 8 unit of labor input does not raise output. Whether firm applies 7 or 8 units of labor input to a fixed amount of capital input, total output remains 224 units. Beyond this point, using more units of labor input is counterproductive because output declines as use of labor is increased. So, there is a relationship between the concept of the total product and labor. Here, there is one thing else. One thing is more important: what is average product and what is marginal product. Average product. The average product of an input can be defined as total output divided by the amount of input used to produce that output. That means APL equal to Q by L. APL, average product of labor, Q is the total output or total product, L is the amount of labor. In the column, you see that in the third column, the average product is shown, where the average product for each quantity of labor is derived by dividing total output in column 3 by corresponding amount of labor in column 2 that produces each output labor. Then the marginal product. The marginal product of an input is defined as the change in total output due to a unit in the use of an input while quantities of other inputs are held constant. For example, with capital fixed at 5 units, when the amount of labor increases from 3 to 4 units, total output increases from 120 to 160. So the marginal product of labor when 4th unit of labor input is employed is 40 units of output. That means MPL equal to delta Q by delta L. MPL equal to marginal product of labor. Delta Q is the change in output. Delta L the change in labor input. Like the average product, the marginal product the marginal product also increases initially and then falls and finally becomes negative. In the present example, we see that the marginal product of labor becomes negative when labor input exceeds 8 units. This happens when the variable input is used too intensively with the fixed input. The marginal product is greater than average product when average product is rising. It is equals average product or MR equal MP equal to AP equal when average product is maximum or AP is maximum, that time AP equal to MP, and is less than average product when average product is falling. So this proportion is true of all marginal and average relationship. Then total average marginal product curves. When we plot these points, we get the marginal curve, marginal product curve, margin average product curve, and total product curve. Then the total output increases at an increasing rate up to point E. In the diagram 7.1, this figure you can see it. At up to point E, as more labor is used, the point E where total product stops increasing at an increasing rate and begins increasing at decreasing rate is called the point of inflection. That means E is the point of inflection. Up to point E, it is increasing at increasing rate. After that, it is increasing but in decreasing rate. Total product reaches a maximum at 224 units when 7 units of labor input are used. The use of an additional unit of labor input at this stage does not lead to any increases in total product. Beyond this point, further use of labor input results in a fall in total output. That means up to 7 it is highest in production. That proportion of total product is shown by dash, which indicates that after that point it is declining and increasing of employment, increasing of labor cannot increase the production. When a labor input is expanded beyond 18 units, output falls, which means that production is not technically efficient and is thus not a part of the production function. Then B shows the average and marginal product curves of labor. In this figure 7.1, below total product curves, below figure is show the marginal product curve and average product curve. Here we can see the units of the vertical axis have been changed from output per period, from period of time to output per unit of labor. Hence, average product and marginal product curves measure the output per unit of labor. The use of labor input increases initially. The marginal product of labor increases, reaches a maximum at 3 units of labor and then declines. The marginal product of labor in our example becomes 0 at 8 units of labor and thereafter turns negative. However, technical efficiency rules out the possibility of negative marginal products and therefore not a part of the production function. The average product of labor also increases initially, reaches a maximum at 4 units of labor output and then declines. So, when marginal product increases, average product also increases, though at the rate lower than that of marginal product. It is important that even when marginal product starts decline but remains greater than the average product, the latter shows a tendency to increases. Then when the average product is maximum, the marginal product is equal to it. This is the reason why the marginal product curve intersects the average product curve at its highest point. Beyond this point, when the marginal product declines, it also pulls down the average product. However, the rate of decline in the average product is less than that of the marginal product. Then the relationship between TP and MP. As long as marginal product is positive, total product curve will continue to rise. When marginal product is zero, total product curve reaches its highest point. It may be that when earth unit of labor input is employed, marginal product of labor becomes zero and total product is at the maximum. Thereafter, marginal product of labor is negative and total product curve has downward slope, which means that total product falls. So, to the law of variable proportion is derived to base of this marginal product and average product curve. Production reveals that as more and more of some inputs is employed, all other input quantities being held constant. Normally, marginal and average product increase up to a point. Thereafter, marginal product starts declining and this pulls down the average product also. In the production process, generally, land, capital, equipment, and buildings remain fixed in the short run, while quantities of labor and raw materials can be varied. However, we may consider a case where amount of capital is fixed and the quantity of labor is increased. In this case, initially the marginal product of labor will increase as its amount is increased, and the marginal product will also pull up average product with it. In this situation, total product increases at an increasing rate. Then variable input, suppose labor. When labor is further increased, marginal product stops increasing after a point. Therefore, the rate of increase of total product also shows a tendency to fall. Ultimately, marginal product turns negative. This causes a fall in total product itself. So, the changes in technology are ruled out. The tendency of marginal product to decline after a point is inevitable. These statements of trends in marginal product in response to changes in the quantities of variable factors applied to a given quantity of a fixed factor is called law of diminishing return. It is also known as the law of variable proportions because it predicts the consequences of varying the proportion in which factors of production are used. As it is also followed that as equal increments of one input are added, the inputs of other productive services being held constant. Beyond a certain point, the resulting increments of product will decrease. That means the marginal product will diminish. The law of variable proportion can be easily understood with the help of a table. In this table, as the amount of labor employed increases, the total output also increases until the seventh unit of labor is employed. Initially, the increase in output takes place at an increasing rate because marginal product rises. This tendency is observed up to the point E, where marginal product reaches a maximum. At point E, which is the point of inflection, the rate of increase in total product from increasing to decreasing because marginal product begins to diminish. After point E, marginal product starts to diminish. However, average product continues to increase until it reaches a maximum 8.8 on total product curve. When the amount of labor is further expanded, total product continues to increase, though at a diminishing rate. Both marginal product and average product remain positive, but both continue to diminish. Then, any attempt to increase output beyond this point after the point G, any attempt to increase output beyond this point by employing more units of labor will not be fruitful. It will be counterproductive because marginal productivity is negative, which implies that total product diminishes. So the product curves such as that are general representations of production function with fixed and variable inputs. Similar product curve could be drawn through each different from others in same way. The stage of increasing marginal product may be long or brief or can be totally absent. Moreover, when marginal product diminishes, the rate at which it happens may be different in each case. So, total in this properties of product curve, this is this is shown in the table. Total product, marginal product, and average product. First, total product increases at increasing rate. Then rate of increase changes from increasing to diminishing. When total product increases, marginal product also increases, average product also increases. It is going to the up to the point E. Then when the marginal product reaches its maximum point, after that that starts diminishing, but average product continues increases. That time what happened? Total product increases, but increasing to diminishing at point E and H. This is under stage 1. Then stage 2, in stage 2, total product continues to increase at diminishing rate. Marginal product continues diminishing and average product reaches a maximum where it equals with MP. Then starts diminishing. It is shown in the diagram at point F and Z. Then reaches a maximum and then starts diminishing up to this point. It is stage 2 becomes when marginal product becomes 0 and average product continues diminishing at point G and K. This is stage 2. And in the stage 3, total product diminishes, marginal product is negative, and average product continues diminishing. The three stages of production. Stage 1 is characterized particularly by the rising average product. Stage 1 occurs when labor is employed from 1 to 4 units. In stage 1, total product first increases at an increasing rate and the marginal product rises. It reaches a maximum at labor output of 3 units when 4th unit of labor input is employed. Diminishing returns set in implying that total product increases at a diminishing rate and the marginal product falls. In stage 2, total product increases at a diminishing rate and thus both marginal product and average product decline. Marginal product being below the average product pulls the latter down. The right hand boundary of stage 2 is at maximum total product where marginal product reaches 0. It is stage 2 ranges from 4 to 8 units of labor. Then stage 3, total product falls and marginal product is negative. And stage 3 occurs when labor is employed in excess of 8 units. Actual stages of operation. In stage 1, average product of the variable input is increasing. Therefore, if the amount of variable input is double, the output more than doubles and the unit cost of producing output decreases. If a farm is operating in a competitive market, it would avoid producing in this stage because by expanding output, it reduces the unit cost while the price it receives remains the same for each additional unit sold. This means that total profits increase if production is expanded beyond the regional pricing average product. Then, initially, the variable factor or labor is not able to use all the capacities of the fixed factor. Hence, MP and FP remains low. For that, one worker may not be able to make full use of the potential of 1 hectare plot of land. But two workers together are in better position to work on that field. Hence, rise in MP as labor increases from 1 to 2. So, a rational producer will operate in the second stage only when the law of diminishing marginal return operates. This is why the law of variable proportion is also called the law of diminishing marginal returns to a factor. Then, and according to modern economists, when in the initial stage of production, quantity of the variable factor is increased. The tendency of increasing returns in production operates. So, Marshall opined that the tendency of increasing returns operates only in the manufacturing industries. He believed that when the quantity of labor and capital employed in the manufacturing industries is increasing, the scale of production expands and this leads to a better organization of production. But John Robinson explained this increasing returns is more scientifically. When an increased amount of any factor of production is devoted to a certain use, it is often the case that improvements in organization can be introduced which will make natural units of the factor more efficient so that an increase in output does not require a proportionate increase in the physical amount of the factor. That, that means the tendency of increasing returns operates not only in manufacturing industry but in all productive activities. The tendency of increasing returns comes into operation because the efficiency of the factors of production is improved. Then, optimum combination of factors of production. According to John Robinson, full exploitation of some individual factors of production is not possible until increased quantities of some other factors of production are employed. Therefore, when the producer engages a small quantity of different factors of production, an optimum proportion among them is not established and the level of production remains low. When the increases the quantity of those factors of production which were employed less, marginal product increases till the point is reached where the factors are combined in optimum proportion. Naturally, at this point, output level is maximum. Then large size of fixed factors. When the size of the fixed factor used for producing a given good is very large, while the quantity of the variable factor is used is very small, the level of efficiency remains very low. As more and more quantities of the variable factors are employed, marginal productivity increases. As the division of labor and specialization will lead to increasing returns as marginal production will rise rapidly. Then constant returns to scale. On continuously increasing the quantity of variable factors of production in a farm, the marginal product neither increases nor decreases, but remains constant. This is case of constant returns. There is no industry in which Increase in the quantity of variable factors of production yields constant returns permanently. But according to Marshall, if the action of the law of increasing and diminishing returns are balanced, we have the law of constant returns. According to him, this law can operate only when there is a balance between the increasing returns and diminishing returns. But modern economists regard the area of operation of constant returns as fairly large. According to them, constant returns is generally found to operate before the diminishing returns sets in. Whether it is agriculture, manufacturing, industry, or any other productive activity, the tendency of increasing returns can operate only up to a certain limit. After this limit, it it is reached. Constant returns operate for some time from the point of view of the producer. This is an important stage because of exhibits an optimum combinations of the factors of production. In this stage, marginal cost is the minimum. So, therefore, the stage of constant returns is very significant from the point of view of the producer. So, producers prefer constant returns to scale. Then, diminishing returns. The diminishing returns stage is the most important of the three stages of the law of variable proportion. In economics, the explanation of the law of diminishing returns is presented in two ways. The classical economists believe that this law applies only to agriculture. But modern economists like John Robinson, Stigler, etc. constitute the second category of economists. These economists regard the law of diminishing returns of far greater applicability than the classical economists. According to them, this law operates in all areas of productive activity. According to Marshall, an increase in the capital and labor applied in the cultivation of land causes in general a less than proportionate increase in the amount of produce raised unless it happens to coincide with an improvement in the arts of agriculture. That means when land is kept fixed in agriculture, while the quantity of labor and capital applied on that land is increased, total production increases, but not in the same proportion as the factors of production are increased. It increases by lesser proportion. As against the view of Marshall, modern economists like John Robinson explain the law of diminishing returns in separate manner. Accordingly, they have presented this law in a general fashion, as would be clear from his definition. According to him, the law of diminishing returns, as it is usually formulated, states that with fixed amount of any one factor of production, successive increases in the amount of other factors will after a point yield a diminishing increment of the product. That means the law of diminishing returns is a logically necessity when in any productive activity the quantity of the variable factor of production employed with given quantity of fixed factor of production is increased, the law of diminishing returns sets in after the point of optimum proportion has been reached. Initially, application of variable factors was sub-optional given the size of fixed factor. Later, the expansion in use of variable factors leads to sub-optimally of a different kind. Another important reason for the operation of the law of diminishing return is that one factor of production is used in a fixed quantity. Had all the factors of production been available in abundance and had it been possible to increase their use in production to all coincidable limits, the law of diminishing returns would not operate. However, all factors of production, land, labor, capital, enterprises, organization, etc., are scarce, and often the supply of one of these is taken to be fixed. It is the factor that results in diminishing returns. Because of the diminishing returns operate. But according to Marshall, is not give importance to the diminishing returns, but other modern economists give more importance to this law, to this diminishing returns to scale. Then production with two variables. We discussed about the production with one variable. Now we come to another chapter, that is production with two variables. We know that if a farm has a given quantity of labor, land, and machinery, the level of production will be determined by the technical and engineering conditions and cannot be predicted by the economist. The level of production depends on technical conditions. If there is an improvement in the technique of production, increased output can be obtained even with the same quantity of quantity of factors. So, at a given point of time, there is only one maximum level of output that can be obtained with a given combination of factors of production. This technical law, which expresses the relationship between factor inputs, is known as the production function. The production function describes the laws of production, that is, the transformation of factors inputs into products at any particular period of time. Further, the production function includes only the technically efficient methods of production. This is because no rational entrepreneur will use inefficient methods. So, according to him, assume that there are two inputs, labor and capital. We can right there, we can know that the production function Q equal to function of L and K. Then the production function is known from the isoquant curve. Isoquant means what is isoquant? And isoquant is the locus of all the combinations of two factors of production that yield the same level of output. Let us suppose that a farm wants to produce 100 units of commodity X, and for that purpose can use any one of the 6 processes. Then process 1, 2, 3, and units of labor, units of capital. In that there is two inputs, labor and capital, and their combination is when it used to produce 100 units of eggs, the first process is clearly capital intensive. At that time, it can use factor substitutes or it use more capital and less labor. That is capital intensive technique. Then come to then third technique is the labor intensive technique, where it can use more labor and less capital. And the third process is the most labor intensive or the least capital intensive. We can constant it capital intensive, then labor intensive. And second is the both are equal, labor and capital. When we put this schedule into a diagram, we got a isoquant curve. That means at first time it used 7 units of capital and 2 units of labor. And second method, it can use 4 units of labor and 4 units of capital. And in third technique, it can use 6 units of labor and 3 units of labor. When we plot these points and draw a diagram, we got isoquant curve. Then types of isoquants. Isoquants are three types: convex isoquant, linear isoquant, input-output isoquant. Then the traditional economics theory has mostly used the convex isoquant, which is sloping downward to the right, and it is convex to the origin. The isoquant can assume some other shapes depending on the degree of the substitutability of factors. The two other possible production isoquants are linear isoquant and input-output isoquant. Linear isoquant. In case of perfect substitutability of the factors of production, the isoquant will assume the shape of a straight line sloping downwards from left to right. And it is shown that when a quantity of labor is increased, the quantity of capital can be reduced by same manner and at constant level. Output level is same. Likewise, on increasing the quantity of labor and increasing of quantity labor and reduce of the quantity of capital is in the constant manner, so that the isoquant curve is like a straight line. It is linear isoquant, and it implies that a given commodity can be reproduced by using only labor or only capital, or by infinite combination of labor and capital. In the real world of production, this seldom happens. Therefore, a linear downward sloping isoquant can be taken only on as an exceptional case. Then input-output isoquant. When factors of production are not substitutes but complementary, technical coefficient are fixed. The meaning of this statement is that optimum output is obtained only when the factors of production are used in a fixed proportion. In this situation, if a producer uses one factor of production in excess of what is required by fixed proportion, there will no increase in output. In the case of complementarily of factor of production, the shape of the isoquant is right angle or like the letter L. As would be clear from the figure, the isoquant is formed by two straight lines, one vertical and the other horizontal. And these two lines are perpendicular to each other. So, in this type of isoquants are called Leontief isoquant. It is named after Wassily Leontief. And it is otherwise known as input-output analysis. Input-output isoquant does not imply that by increasing the quantities of the two factors of production, labor and capital, the output will increase proportionately. It implies only that for producing any quantity of a commodity, capital and labor must be used in a fixed proportion. So, slope of isoquant indicates capital labor ratio has to maintain the for ensuring efficiency in production. Then isoquant map. There are always number of isoquants for a producer levels of production. Isoquants nearer the point of origin represent relatively lower level of production. The level of production increases as one moves away from the origin and goes to higher isoquants. So, a complete set of isoquants for the product is called an isoquant map. So, there is some assumption of isoquants. It is generally assumed that there are only two factors or inputs of production. Second, the second assumption of the isoquant analysis is that the factors of production are divisible into small units and can be used in various proportions. Then third assumption is technical conditions of production are given and it is not possible to change them at any point of time. Means technical conditions of production are given and constant. Then, given the technical conditions of production, different factors of production are used in the most efficient way. To the base of these assumptions, the isoquants properties are described. Then, properties of isoquants. Isoquants are negatively slow. Normally, isoquants slopes downwards from left to right implies that they are negatively slow. The reason for this characteristic of the isoquant is that when the quantity of one factor is reduced, the same level of output can be achieved only when the quantity of the other factor is increased. These characteristics of the isoquant assume that in no case marginal productivity of factor will be negative. In a more realistic case, when the assumption is dropped, one may find an isoquant which bends back upon itself or has a positive slope segment. So, the first properties isoquants are negatively sloped. Then a higher isoquants represent a higher output. A higher isoquant is one that a further from the point of origin, which is a further point from the origin. That is the higher isoquant. In the set of isoquants map, we can find that which is nearer to the origin, that is give the less satisfaction, but which is far from the origin, that gives the more production. It gives the larger output that is obtained by using either the same amount of one factor and and other and the greater amount of the other factor or the greater amounts of both the factors. Third property, no two isoquants intersect or touch each other. The two isoquants are never touch or intersect with each other. Isoquants do not intersect or touch. It represents that if, for example, isoquants P and P2 represent output level 100 and 200 units respectively, their intersection at some point, say A, would mean that two output levels 100 and 200 will be reached by using the same amount of capital and labor, which is not likely to happen, which is not possible. So, no two isoquants will touch each other. Then four, isoquants are convex to the origin. We know that the factors of production have substitutability used in production processes. Often, labor can be substituted for capital and sometimes capital can be substituted with labor. The rate at which one factor of production is substituted for the other in a production process, that is the marginal rate of technical substitution, that tends to fall. That means in the isoquant curve, the MRTS always falls. Marginal rate of technical substitution of factor L for factor K is the quantity of K that is to be reduced on increasing the quantity of labor by 1 unit of keeping the output level unchanged. The isoquants are convex to the origin because the marginal rate of technical substitutions tends to fall. Then economic region of production and rigid lines. Generally, production functions generate isoquants which are convex to the origin. Negatively sloped throughout do not intersect each other, and the higher the isoquants, greater the level of output. However, There are some production functions which yield isoquants having all the properties of a normal isoquant except that they are not negatively sloped throughout. In other words, they have positively sloped segments. So, in the let us consider isoquant as AB segment of this isoquant has a negative slope beyond points A and B in the diagram 8.9. This isoquant is positively sloped. Similarly, other isoquants have the points where they bend back upon themselves, imply that they become positively slopes. The lines OK and OL joining these points are called ridge lines. They form the boundaries of the economic regions of production. And here, in this case, suppose the output represented by isoquant P3 is to be produced. For producing this quantity, a minimum of OK2 amount of capital is required because any smaller amount will not allow the producer to attain the P3 level of output. With OK2 amount of capital, OL2 amount of labor must be employed. The producer uses an amount of labor less than OL2 together with OK2 amount of capital, his output level would be lower than the one represented by isoquant P3. So, because use of inputs in smaller amounts would yield a smaller output, but combining labor input in an amount larger than OL2 with OK2 amount of capital would also result in output smaller than that is represented by the isoquant P3. So the P3 level of output with a larger labor output capital input also in a large amount has to be used. Obviously, this is something which no rational producer would attempt because it involves uneconomic use of resources. Point B on isoquant P3 represents the intensive margin for labor because an increase in the amount of labor input beyond OL2 with a fixed amount of capital input OK2 does not increase the labor output level. At this point, marginal product of labor is zero, and thus the marginal rate of technical substitution of labor for capital MRTSLK is zero. This implies that at point B, labor has been substituted for capital to the maximum extent. Thus, to the right of range line OL, we have stage 3 for labor. So for producing P3 level of output, a minimum of OL one amount of labor input is required. A smaller amount of labor input will not allow the producer to attain P3 level of output. With OL1 amount of labor, OK1 amount of capital must be used and any addition to capital input beyond OK1 would not increase output. So at point A on P3, capital has been substituted for labor to the maximum extent. Thus, above rise line OK, we have stage 3 for capital. The MRTS KL is 0, which means that the marginal rate of technical substitution of labor per capital is infinite. The line OK in the figure 8.9 connects the point of 0 marginal product of capital. We have it at the upper ridge line. Similarly, the line OL designed at the lower ridge line joins the points of 0 marginal product of labor. The combination of labor and capital inputs compromise the area between ridge lines of OK, and OL constitute the generalized stage 2 of production for both resources. These are the combinations that are relevant for production decisions. Then optimum combination of factors and produces equilibrium. Then a producer may attempt maximization of output subject to a given cost. He may seek to minimize cost subject to a given level of output. In both cases, for choosing optimum quantities of two inputs, example labor and capital, he must consider their physical productiveness as well as their prices. While isopoints represent the productivity of the inputs, their prices are shown by isocost lines. An isocost line represents various combinations of inputs that may be purchased for a given amount of expenditure, that is the producer's budget. So, the an isocost line represents various combinations and which the producer and their prices which can the producer purchase for the production. The producer has to purchase factors from the market. How the prices of labor and capital are determined in the market is depend on the producer's expenditure. The firm is in no position to influence the input prices unless it is a monopolist or oligopolist. Prices of labor and capital have to be taken as given by the firm operating in a competitive sector market. So, the slope of the isopoint isopost line is like the budget line of consumers' behavior. And isocost line is means delta K by delta L means expenditure delta change in the capital by change in the labor. The isocost line is similar to the budget line of the consumer. There is an important difference between the two lines. The consumer's budget is inversely fixed. He has a single budget line. The firm generally has no such constraint and thus has more than one isocost line. In the figure, we see this. We have shown there are three isocost lines. There can be many more of them corresponding to firm's cost outlay plans to attain various output levels. So, an isocost line further to the right reflects higher cost. The one closer to the origin reflects lower cost. So, today we know about the producers curve, isopoint line, isocost line, and isopoints map, and the characteristics and properties of isopoints. Tomorrow we learn or discuss more about this, the producer's behavior.